There's a number sitting in a public science database right now that nobody can explain. Not a rumor, not a leak. A number, 5.11 microns. That's it. That's the whole mystery. And somewhere between that number and the two coldest, strangest worlds humanity has ever photographed, something is happening that scientists cannot name, cannot classify, and cannot walk back. Read that again. They cannot walk it back. Because once you see this signal, you cannot unsee it. And once you understand what it might mean, you start to realize that Pluto, the little frozen afterthought we all stopped caring about in grade school, just became one of the most disturbing puzzles in the solar system. For most of your life, Pluto was a punchline. Demoted in 2006, reduced to a dwarf planet. A frozen rock too small and too far to matter, sitting alone in the dark at the edge of everything, 4 billion miles from the nearest working streetlight. In 2015, NASA's New Horizons spacecraft screamed past it at over 30,000 miles an hour, took its pictures, and left. And in those pictures, Pluto looked almost gentle. Icy plains shaped like a heart, frozen mountains. A pale blue haze wrapped around it like a shawl. It was beautiful. It was quiet. It was, everyone assumed, done being interesting. Here's where it gets worse. Because Pluto was never done. It was just waiting for the right instrument to ask it the right question. And in 2026, that instrument finally showed up. The James Webb Space Telescope wasn't built to stare at Pluto. It was built to look back in time, toward the first galaxies, toward the edge of the observable universe, 13 billion years into the past. Pluto is a rounding error compared to that mission. And yet, almost as a side project, almost as an afterthought, scientists pointed Webb's mid-infrared instrument at Pluto and at Titan, Saturn's giant moon, and asked a much smaller, much quieter question. What wavelengths of light are these two worlds absorbing that we haven't looked at before? What they found should not exist. Every material in the universe has a signature, a fingerprint written in light. When sunlight hits a surface, ice, rock, gas, anything, certain wavelengths get swallowed up, absorbed, and vanish from the reflected spectrum. Scientists have spent decades building a library of these fingerprints. Methane leaves one mark, nitrogen leaves another, carbon monoxide, ethane, acetylene. Every known molecule in the solar system has a matching signature already logged, already understood, already filed away in a catalog that took generations to build. Webb found a fingerprint that isn't in the catalog at exactly 11 microns, in the mid-infrared range that had barely been explored before. A very specific, very deliberate dip appeared in the light coming back from Pluto's surface. Not from its atmosphere, from its surface. The researchers checked. They compared the center of Pluto's disk to its edges, because if the signal were coming from gas in the atmosphere, it would get stronger at the edges, where sunlight has to cut through more air to reach the telescope. It didn't. It got weaker at the edges, which means whatever is causing the signal isn't floating above Pluto, it's sitting on it. Something is coating the surface of this dwarf planet that has never been identified anywhere else in the observable universe. But here's where it gets worse. They didn't stop at Pluto. They checked Titan too. Saturn's massive moon, bigger than the planet Mercury, wrapped in a thick orange atmosphere. The only other place in the solar system besides Earth known to have rivers, lakes, and rain. Titan is not like Pluto. Titan has weather. Titan has an active methane cycle. Titan is, by every measure that matters, a completely different kind of world. And when researchers checked Titan's spectrum at that same wavelength, at 11 microns, the exact same absorption signature was staring back at them. Think about what that means. Two worlds, separated by billions of miles, separated by size, temperature, geology, atmosphere, history. One is a small frozen dwarf planet in near total darkness at the edge of the solar system. The other is a massive active moon orbiting a gas giant, with its own internal weather, its own methane rainstorms, its own strange and living-seeming chemistry. They should have almost nothing in common, and yet both of them are marked by the exact same unidentified signature, at the exact same wavelength, appearing nowhere else that anyone has ever looked. This is not a coincidence, and scientists know it. The team that made this discovery went back through every published planetary spectrum they could find. Every known ice, every known hydrocarbon, ethane, propane, benzene, hydrogen cyanide, acetylene ice, ketene ice. They lined up every known chemical signature humanity has ever cataloged side by side against this 11 micron dip. According to the researchers' own written conclusions, none of it matched. Not one existing compound explains what they're seeing. In their own words, they searched the literature and did not find a single reference band that corresponds to this location. That sentence, buried inside a scientific paper, is as close to a confession of genuine confusion as modern astronomy gets. What most people are not seeing is how rare this actually is. Astronomers find unexplained signals all the time. Small dips, faint noise, statistical quirks that get explained away within a year once someone in a lab replicates the right ice under the right pressure. That's normal. That's the background hum of planetary science. This is not that. This is a repeatable, confirmed, unmistakably real signal, showing up in the same place, on two unrelated worlds, at strengths too consistent to be noise and too specific to be a mistake. The scientists aren't debating whether it's there. They're debating what it is. That distinction matters more than almost anything else in this story, and this is where everything changes. Because if the same unidentified material exists on both Pluto and Titan, two worlds that share almost nothing except one crucial detail, an atmosphere and surface chemistry built on methane and nitrogen, then researchers are suddenly staring at the possibility of a shared chemical process happening across the outer solar system. Not a coincidence, a pattern. A process that might be quietly manufacturing an unknown compound anywhere. The right ingredients and the right cold exist, from the icy plains of Pluto to the methane lakes of Titan. And possibly, though no one has confirmed this yet, on other icy bodies, scientists haven't even pointed Webb toward. Here's the detail that should make your skin crawl a little. On Pluto, the signal is roughly 3 times wider than it is on Titan. Same wavelength, same basic fingerprint, but the shape of the dip is different. Deeper and broader on the dwarf planet, thinner and sharper on the moon. In spectroscopy, shape is not decoration. Shape is information. A wider absorption band usually means the molecule exists in a different physical state, packed differently, layered differently, possibly mixed with other unknown materials in a different ratio. Whatever this thing is, it isn't behaving identically on both worlds. It's adapting. It's showing up differently depending on where it lands. And on Titan, it gets stranger still. The signal isn't even spread evenly across the moon. It's noticeably stronger on Titan's trailing hemisphere, the side of the moon facing away from the direction it travels in its orbit around Saturn, than on the leading side that faces forward. That kind of asymmetry usually points to something actively depositing material unevenly across a surface, shaped by orbital dynamics, radiation exposure, or particle bombardment from Saturn's surrounding environment. In other words, this isn't a static leftover from billions of years ago, sitting quietly in the ice. Something about this material's distribution suggests an ongoing process, something that is still happening. Read that again. Still happening. According to informed analysis from the researchers who authored this study, the leading theoretical candidates right now include large, ring-shaped hydrocarbons like benzene, mixed with something else not yet identified, or exotic ices built from compounds like alans and keton. Chemical structures that, under normal Earth conditions, barely exist outside a laboratory, let alone survive for billions of years exposed to the vacuum and radiation of deep space. If either of these candidates is correct, it would mean these two frozen worlds are quietly hosting complex organic chemistry that scientists assumed was too fragile, too exotic, or too improbable to persist naturally in the outer solar system. This is not chaos. This is chemistry writing a message nobody can read yet. And the stakes of that message are bigger than they first appear. For decades, the search for life beyond Earth has been obsessively focused on liquid water, the assumption that if life exists anywhere else, it needs water as its foundation, just like it does here. Titan broke that assumption years ago when scientists confirmed methane lakes and rivers flowing across its surface, raising the uncomfortable possibility of chemistry, maybe even biology, built on a completely different foundation than our own. Now Pluto, a world with almost no atmosphere, a world sitting in permanent, brutal cold 4 billion miles from the sun, is showing traces of the exact same unexplained organic signature. If Pluto can host whatever this is, then the assumption that complex chemistry needs warmth, needs light, needs anything resembling Earth-like conditions starts to collapse. What most people are not seeing is how this reshapes the entire search for life in our own backyard. Every mission plan, every budget proposal, every argument for where humanity should send its next spacecraft has been built on a hierarchy of likely targets. Mars first, then the icy moons of Jupiter and Saturn, with Pluto treated as a curiosity, a place we already visited once and can safely deprioritize. This discovery quietly breaks that hierarchy. If an unidentified, possibly organic-rich material can survive and even actively redistribute itself on a small, cold, atmosphere-thin dwarf planet at the edge of the solar system, then the entire model of where interesting chemistry can exist needs to be rebuilt from scratch. But here's where it gets worse again. Nobody currently has a spacecraft anywhere near Pluto capable of confirming any of this directly. New Horizons flew past in 2015 and kept going, deeper into the Kuiper Belt, never to return. There is no orbiter. There is no lander. There is no way right now to physically sample whatever is sitting on Pluto's surface and run it through a laboratory instrument to get a definitive answer. Everything scientists know about this mystery comes from starlight, bounced off ice 4 billion miles away, captured by a telescope that wasn't even designed with this target in mind. The most important open question about the outer solar system in a generation is being investigated entirely by remote inference, with no follow-up mission currently funded to go and check. Think about what that means for how long this mystery survives. Confirming the signal in a laboratory means recreating conditions that barely exist anywhere on Earth. Extreme cold, near total vacuum, decades or centuries of radiation exposure compressed into an experiment that might take years to design correctly. Scientists have to synthesize candidate molecules, freeze them into ice at temperatures approaching absolute zero, expose them to the kind of ultraviolet and cosmic radiation these surfaces experience over unimaginable stretches of time, and then measure whether the resulting spectrum matches that exact 11 micron dip. That is not a quick experiment. That is potentially years of laboratory work, chasing a signal that 4 billion miles of empty space refuses to explain any faster. And here's the part that should genuinely unsettle you. This paper, describing one of the strangest unexplained findings in modern planetary science, was only posted as a preprint in June of 2026. It has not yet completed formal peer review, which means the broader scientific community is still in the earliest stages of scrutinizing it, testing it, trying to break it. Some of it may hold up perfectly, some of it may get revised, but the core detection, the repeated, unmistakable dip at 11 microns, present on 2 unrelated worlds, has already been independently noted across multiple research write-ups in the weeks since, each one treating it not as noise, but as a real and urgent scientific puzzle. The real story is not that NASA is hiding anything. Nobody buried this. It's sitting in an open preprint server that anyone with an internet connection can read right now. The real story is quieter and, in some ways, more unsettling than a cover-up. Humanity built a $4 billion telescope to stare into the deep past of the universe, pointed it almost as an afterthought at a demoted dwarf planet in its own solar system, and immediately found something it cannot explain. Not a conspiracy. A blind spot. A reminder that the objects closest to us, the ones we assumed we already understood, can still contain mysteries our best instruments have never been sensitive enough to catch until now. And this is where the bigger picture opens up. Because if a single afterthought observation of Pluto produced a fingerprint with no match anywhere in the known universe, what else is sitting in Webb's archives, quietly unanalyzed, waiting for someone to ask the right question? Every icy moon in the outer solar system, Europa, Enceladus, Triton, the countless smaller Kuiper Belt objects still uncatalogued in detail, has now become a candidate for hosting whatever chemical process is responsible for this signature. This isn't just a story about Pluto anymore. It's a story about how much of the solar system we've been looking at without actually seeing. What comes next depends entirely on decisions that haven't been made yet. Whether more Webb observing time gets allocated to map exactly where on Titan this material is strongest, and whether it can be matched to specific surface features. Whether laboratory teams succeed in recreating a molecule that matches the signature under the brutal conditions of deep space. Whether funding ever materializes for a return mission to Pluto, decades after New Horizons said its one and only goodbye. None of that is guaranteed. Science does not move at the speed of curiosity. It moves at the speed of budgets, review cycles, and competing priorities across 100 other unsolved mysteries fighting for the same limited resources. So the number stays there for now. 5.11 microns. Unassigned, unexplained. Sitting quietly in the light, bouncing off 2 of the coldest, strangest, most overlooked worlds in the solar system, refusing to match anything humanity has ever cataloged. Maybe it turns out to be something almost mundane. An exotic ice. A known compound behaving strangely under extreme conditions. A chemistry problem that gets solved quietly in a laboratory within the next 2 years and forgotten by everyone except the specialists who worked on it. Or maybe it turns out to be something none of us are prepared for. Nobody knows yet. And that, more than anything else in this story, is the part worth sitting with. Somewhere out past Neptune in permanent cold and permanent dark, something is written into the ice of Pluto that no scientist on Earth can currently read. The question is no longer whether it's real. The question is, what happens the day someone finally does?